And then we'll go. Okay, we're dealing with logarithmic functions. You probably want to get out your packet and turn it to page 18. Now, page 17, 18, 19, and 20 have some overlapping material in them. I'll tell you that ahead of time. Okay, the first thing we're going to be doing is converting between logarithmic and exponential form. Okay. So here, this is called a logarithmic function. Y equals log b of x is how you say that. Okay. With base b. And this and that exponential equation that we've been dealing with the last few days are equivalent statements. This is equal to that. They're just in different form. Okay. It's kind of like the idea of standard and vertex form of parabolas. Okay. And one of the things I'm going to be showing you is how to convert between those two. Now, something that's important for you to know about both of these is that both of these are inverse of the exponential functions we've been working with and graphing already. Okay. Now, if we had b to the x equals y, then b to the y equals x would be an inverse of each other because you've interchanged the variables. Okay. So if this is the inverse of that, which is what we've been doing, then this also is the inverse of that. So it's kind of important for you to know that fact. In terms of language, here's your base, okay? X is called the argument, where its location is, no matter what variable it is or number. And then they call this the logarithm, I call it the power. So you'll see why as we get into some problems. Okay, now, this, by the way, anytime you just have log without a base specified, it's a hidden log base 10. Okay. Now, it doesn't matter what base you would have, but this particular item where you have a negative argument is undefined. Okay. You can't have a value there. Now you can have negative power on that x, okay, which just means reciprocal, but you can't have the whole value negative. All right, so that would be no solution if this were the case. All right, here we go. Now, I need to teach you what to think you see this thing. If you didn't know this 5 was here, okay? If you didn't know this 5 was here, 2 to what power is 32? 2, 4, 8, 16. Can't hold them all up because I dropped my wand here. But the 5th power, okay? That's what I want you to think. A lot of the times, they'll just say, evaluate this. And they won't tell you that. Well, in this case, what we can do is we can switch this to exponential. That's the exponential form of this. Okay? And indeed, 2 to the 5th is 32. So there's your path to convert them. And, you know, you can go from one to the other or the other to one. The base always remains the base. Here is your power. That's why I call it power. And then here is your argument. The argument that 2 to the 5th gives you 32 is a true argument. Now, what about this one? 10 to what power is 1,000th? Well, they're already telling you it's 83. Okay. But what we're thinking here is this also could be characterized as 10 to the 3rd, right? So, and this could also be characterized as 10 to the negative 3rd. That's why we got that -3. Okay. See how you can reason these things? And then here's the exponential form of that. 10 to the negative 3rd is indeed 1 over 10 to the 3rd, or 1 over 1,000. Log 5 of 1. Well, they've already told you it's 0, but that falls into your first rule right up here. Log anything of 1 equals 0. Why? Because in exponential form, anything to the 0 power is 1. And that's why that rule works the way it works. Okay. Okay, let's look at these. Log 2 of 16. I didn't put the equals y or a number out here this time. There's a hidden equals y out here on any problem like these. Now, 2 to what power is 16? 4th. So the answer, which I have here, is 4. Okay. What is the exponential on this? 2 to the 4th equals 16. Okay, what about B? 10 to what power is 1,000? 10 to the 3rd. C, 16 to what power is 4? Not half. Oh, are you saying half power? Correct. Correct. Square root of 16 is 4, right? Okay. So therefore, square root means half power when you change it to fractional exponents. So the answer would be 1/2 in this case. Okay. And then finally, the last one. This one's actually like our problem that we had 1 over 1,000, except this is just in decimal form instead of fractional form. 1, 2, 3 places behind the decimal thousands. Okay, so again, -3. Any question about this sheet before I continue? That's on page 18. These 2 rules right here. Anything of 1 equals 0. Why? Because anything to the 0 power is 1. What about this one? Anything to the first power is itself. Okay, does that make sense? Anything to the first power is itself. Look for this, A of A, B of B, Q of Q, whatever variables they might happen to use, because that is a quick simplified step. Okay, anytime you see an A of A, B of B, that sort of a thing, that means it's going to be equal to 1. All right, now all that we're doing right here is we're converting to exponential again. Okay, base, power, argument. But because of the arrows, sometimes that confuses some people. Once again, here are a couple of conversions. This time we're going from exponential to logarithmic. Okay, the base remains the same. Here's your argument, here is your power. Okay, in this case, the base remains the same. Here is your argument, and there is your power. Now, this log E of 30, and we've talked a little bit, I think, about E already, also can be written as just ln. Okay, they can be the same. Now, we can actually get a value of that in our calculator. Okay, this key right up here, is unique to the Casios. I think I've already said that. Okay, and it lets you put in both the base and the argument. So we're going to use that key right now. And we're going to hit that, and we're going to use our alpha E. This is easier if I watch it here instead of back there. Okay, now I'm going to go over and I'm going to put in that 30 that they've got. And I can actually get a value, that's what W would be in this case in reality. Now, I want to show you that you can get that same answer by just simply putting in ln of 30. So I'm going to clear this, hit ln 30 equals, oh, I better close up my parentheses or it'll give me an error, equals, and I get the same value again. Okay, so these are equivalent statements. Just like earlier, I told you if you have log with no base, that it's the same thing as log base 10. Okay. So if you use this log key that I'm pointing at right now, then that means you're doing log base 10. Use this one, it means you're doing log base C. I've kind of hopefully made the point on that. Come to this. Well, here again, we're just going to convert them. The base stays the same. Here is your power. Here is your argument. 7 to the third. 7 times 7 is 49. 49 times 7 is 343. Okay. Down at the bottom, log base B of R. Now we don't know numbers, but we can still convert it the same way. Whatever B is to the 12th power, it would be equal to R. Now, I'm going to go back into this again for a little while. Write them in exponential form. You do that. You do that. I'll give you about 15 or 20 seconds on each one of them to do it. Now check yourself. Okay, now that one. Anyone know why that one works? Well, it changes to this. Five to the negative first can also be written as 1/5 to the first. And 1/5 is 2/10, 20 nickels in a dollar. Okay. So that's why that one works. This one should be easy. That's that first rule on page 18. And this one, actually, this one's just as easy as the other one. Okay, here's some more for us to try. So these are fairly simple. Oh, okay. Now go the other direction. Now, as I put these answers up here, if you have any questions, be sure and stop me right then. What are the powers of 3, 3, 9, 27? We're getting nasty. Okay. Now, I'm not telling you the answer. You got to find the why. 8 to what power is 64? 2. Okay. Now, we put a y out there. Then we do a conversion. 8 to what power is 64? Then it becomes very obvious that it's 2. So here's your final answer. Okay, this one. Now, 125, 5 to the power, by the way. 525, 125. Now you see why I put that exponent sheet in your packet? Some of you have used the calculator so long, you've forgotten things like that. Well, 5 to what power makes a flipped 125? Negative third. Okay, so y in this case is -3. One half times 1/2 times 1/2 is 1/8. So the answer is 3. Yeah. Basically 2 goes into 8 3 times. Since they're both over 1. Okay, here's some more. Okay, here we got a 3. There we got a -2. And here we have a -1. Anything to the first power is itself, except this is a flipped one, so it's a -1. If this had been 3 of 3, the answer would have been +1. You have a question on that one? Oh, okay. All right, what about this one? Anyone remember something I told you about 10 minutes ago? What's the answer? What is y? What? Not 0. Not 0. Yeah. 1. Okay. Anything b to what power is itself? First power is what you need to think on that one. Okay. So it would be the first power. What's this one gonna be? Well, this one's got a kicker in it. Now I'm gonna tell you something that we haven't gotten to yet. Now they're gonna tell you the answer is 7. They're gonna tell you that. Now, when you have a power like that, is you take this and move it out front. Okay, so you would have 7 log C of C equals y. When you got this power up here like this, you bring it out front. Okay, and what is a C of C gonna give me? 1. So that means I have 7 times 1 equals y, or y equals 7 in this case. Now I'll put their screen up there. Base is the same. Okay. Your power. And then they just left that the same and assumed you would know what it is. But I wanted to go ahead and show you that, because if you look on page, let's see. On page 19, okay, right here where my thumb is, there's that power loop. Now this is the regular this is the regular exponents. And here's what it has with logarithms. Notice this P, they brought it out front. Okay. And then you had the rest of it remain the same on whatever you did with it. Okay, well, that's the power that I showed you, the method that I showed you, based on that property. Okay, this one. Well, we need to change this form. We need to change that to a fractional radical. Okay. So let's change it to that. Power of 3 is 1. Power of the root is 4. Remember, the root's always in the denominator. So here I have a power again. Even if this were something besides 3, we would still do that. We have to bring that 1/4 out front. And ultimately, well, let me do it because they're not going to do it. 1/4 times log 3 of 3. This equals 1 times 1/4. So the answer is y equals 1/4. And I think this is simpler than going through the way they did it, where you're trying to reason it out. Yes.
So to get that 4 out off of that radical, you have to make it like 1/4.
Yes. A square root, there's a hidden 2 there, would be 1/2 power.
Okay.
A cube root would be a 1/3 power. A 1/3 power.
Okay.
An 1/8 root would be on 1/8 power. And then whatever the power is in here would be the numerator.
Yeah.
Okay. Here I've got what, number 8 worked. I bring the 10 forward. I've got a b of b, which is equal to 1. So my answer is y is equal to. Over here, I've got to convert it to a fractional, the 1/3 that we just talked about. Okay. So I bring the 1/3 out forward. I've 5 of 5, which is equal to 1. Is 1/3. Quickly, what's the answer? Blurt it out. 2. 12 to the second is 144. Okay. This one's going to be -2 because we're going from bigger to smaller. It's going to be -2. Second are 1/2.
64 with 1/2 top of x's.
4 to the 1/2 power is the same thing as square root of 64. Okay. 1/2 is also equal to 2 to the -1 power. Okay, what about this one? 3, 9, 27. But this is flipped, so it's going to be a -3. Okay. You want me to do those or go on? Okay, now Common logarithmic functions, I've already told you this. If you just see the word log, there's a hidden base 10 there. That's something I've already told you. I've already told you here, log base E and natural log are just simply pronounced ln of x, mean the same thing. Okay, so if we wanted to find the answer to this, then we need to realize there's a 10 here. 10 to what power is 100,000? 10, 100, 1,000, 10,000, 100,000. Yeah, count the zeros. Okay. So here I inserted the base 10. Okay, so I can convert it to exponential. 10 to what power is 100,000? Well, it's the fifth. This one, kind of the opposite direction. This is the same thing as 1 over 100 with a base 10. So our answer is going to be a -2. -2. Okay. Again, that's just repetitious. Though that's repetitious. Okay. Now, what is log of 100? 2. Because 10 to the second is 100. What's a log of 10,000? 10,000th. Easy for me to say. Well, that's 4 digits behind the decimal, which is the same as 1 over 10,000. Okay. So 10 goes into 10,000 4 times, but because it's a decimal or a fraction, it's a -4. Okay, here they're being a little bit tricky on this, and they're not showing it the way I'll show you how I would get this answer. ln of E to the -3rd means the same thing as log E of E. So this part, first of all, we got to take this -3 out front because it's a power. And this stuff right here has a value of 1. So then that's why our answer is -3. Yes.
So you stand for like a concrete number?
Yes, you must have missed class the other day. 2.718 keeps going forever like pi. Okay. And that is a number you need to memorize.
Wouldn't it be, since it was negative, would it be 1/3?
Would it?
Yeah, that's fine.
No. Because again, you bring this up front. This means that, which is 1. So -3 times 1 is -3. We had a similar problem earlier. Log A of A to the 3rd, I think, or 4th. If the answer, let's say a 5th up here, then you bring the 5 out front. So this equals 5 log A of A, which equals 5 times 1, which is
No, I get that. I was just confused.
But
about the
this
negative.
works the same.
I was just confused about the negative. I didn't know.
No.
Okay. I just wanted to.
That doesn't make a bit of difference. Because that is the power of this. If this E had a negative in front of it, then it would be undefined, which is, I think, may have been what would confuse you.
Yeah, I guess it was.
It can have a negative power, okay? The argument can have a negative power, it just can't be negative itself. Okay, here's showing the steps that I put in on the blackboard. What about this one? Well, I mean, we can go through the steps. We can make this N, ln, E. Then we can make this 10, log, E of E. Then we can make this 10 times 1, and we can make it 10. Or we can just realize ln of E is going to be 1. So the answer is 10. Okay. Okay, now let's go a step farther. Get out your calculator. Now here are some examples. And round it off to 4 places. Okay. You can check it by changing to exponential. Be careful or you'll get round off error though. So log 43 of this, see, this is a rounded off value. That's why you've got a slightly different number there and here. Okay. So how do you do that? Well, in that particular case, using the calculator, let's clear this. So we've got, okay, log of 43, we'll do that one. Log 43, close it up, equals that. We could also do in this case, log base 10, scoot over. I wonder what's going on with my calculator. It's being a little weird right now. And 43 in there. And equals, and I get the same value. Okay. Think. Well, let's go ahead and see what happens on these. But you see how to enter those, so I'm not going to show it to you on every one of them. Okay. Just check yourself. By the way, why are they using those approximately's? Because all of these are rounded values. And if you have a rounded value on your test, you better use an approximately or you'll lose 1 point. Not a threat, it's a promise. And I try not to break promises. I very seldom keep threats. Question these. Change of base formula. This is where your calculator, your Casio, with that log anything of anything key pays for itself. Because again, the TIs don't have those. Now, if you've got this, and you did not have one of these Casios, which you could put it in all in one easy pass, then you would have to do this calculation I'm about to show you in order to get the answer where you had a different, where you have got a base different than 10 or E. Okay? Now, this becomes either of these two. Notice here, I have log B of X. Okay? Now we have log base 10 of X. Or just simply log, which we can use in any calculator. And then the B becomes the argument on the other one to base 10. Okay. Now, what is this? This is just simply the base E variation of that. It doesn't matter whether we use just log hidden 10 or whether we use log hidden E with this formula. Now, there have been questions on the final and my test at times, which ask you to use the change of base formula and give your answer in terms of E. Listen to my language. In terms of E. That means I'm looking for an answer like this one. Okay, so if it asks for your answer in terms of E, they're generally looking for this. Okay, now let's do this without that nice key this time. Let's actually use the change of base formula. That's what you should come up with. Now then, let's see if my calculator works. Ah, looks better now. Okay, so let's do what they're saying. We're going to take fraction log of 15 go down to the denominator, log of 7, close up that parentheses. Uh-oh, you know what? I didn't close my parentheses on top. It would have given me an error if I hadn't have done that. So watch out for that, okay? So I'm going to get this thing. And now I'm going to hit my equal key. And you can see I got what they got. Now for contrast, I'm just going to use this key. And I'm going to put in the 7. I'm going to scoot over. I'm going to put in the 15. And I'm going to hit the equal key. Okay, so it saves you some work. And a lot of times what you'll run into is this is the step in the middle of a problem. And that's why that is especially important. Yes. Yes, you're dividing that. Let's play another game. Let's do this. Let's find log of 15. Close it up, equals, is approximately that. 1.176091259. Okay. Now let's clear this thing out and put in log of 7. parentheses equals. And there I get 0.8450980. I'm gonna round both of these off at 4 places, 8451 and 1.1761. Okay. Now then, what I'm gonna do, I'm just gonna do a simple division. I'm gonna put in, okay, let's do fraction. 1.7. Somebody read that to me so I don't have to. No, it's 1.17. $1.17. What next? 6.1. And we'll go down and divide it by 0.8 what? 451 equals. Okay. And so you see, yes, to answer your question, you are dividing those. Okay. Okay, you can see this one. Real easy if you use that key, a little less easy if you don't, but you can still get it with the fraction key. Now, if they have a problem that says use the change of base formula, chances are they're not going to give you a problem that has all numbers in it that you can just punch in the calculator and get an easy number. What we're looking for, both on the final and on my test, is we are looking to see this notation. We're not looking for that. These two, you're going to divide them as that and get this instead of calculating them individually and doing it. Now, there may be some formulas in your future that you might have to do that. Okay. But for now, no. Okay, here we are on property sheet. I think we're back on page 18. Actually, 18 or 19. Doesn't really matter. Okay. Okay, we've talked about these. We've talked about this already. Okay, because this part's 1 times whatever that is. Technically, you bring it out front. Okay. Here's a weird looking B of B. I haven't shown you this form yet. All of this is still 1, and your answer is still going to be X. Okay. This rule, your answer is going to be that power in either case. What's the answer to this? There's no extra power up there other than a 1. The answer is, okay. Log of 10, well, that's a hidden base 10, so it's 1. That's a hidden log E of E, so it's 1. We're getting real. Now, this one. This to what power is equal to 1? 0 power. Okay. Likewise, this to what power is equal to 1? 0. And this one, we've got 1 here. So the answer is going to be 10. Here we've got 1 again. So the answer is going to be -12. Now, this thing. Why is this 14? Because there's a hidden 10 right there. And you've got a 10 of 10. Okay? They're getting devious. That's log 10 of 14. So you got a 10 of 10. Just like here, you've got an 8 of 8. Okay, this is just reminding you that this and that are inverses. So therefore, this and that are also inverses. Okay. Here's the equation, y equals b to the x. Why are we doing this? Because we're headed towards graphing logarithms. Okay. That's why we're showing you that comparison. Actually, 3 forms that you can figure it out from. Okay. So here's B of B graph. Here's the inverse graph. But remember, this one also is the same thing as there we go. This is also the same thing as b to the y equals x. Okay. And if you recall, these things are supposed to reflect across a 45-degree angle. And they do. Now, what does that mean for you? That means that if I gave you this problem, you can convert it to this problem, and then know the inverse is this, graph that inverse, which is pretty easy. It goes through 0, 1, okay, unless there's a modifier, and then just reverse coordinates. Okay, so that's one way you can do it. I want to remind you something we covered before. The domain of this is infinity to infinity. It goes this way forever, and it goes that way forever. Okay. Then, and the range on this stops at 0, but never touches, and goes in infinitely high. Okay. Then, if this is really an inverse, which it is, then the domain value and the range value are just reversed from these two. And that'll get you an answer on a couple of test questions. Just knowing that. Okay, if you exchange coordinates, you exchange domain and range. That's the logic behind that. Now, horizontal asymptote. Yeah, we got one right here. This line approaches x equals 0. Or excuse me, y equals 0. Okay. And in this case, that is a boundary that this will never cross. Now, I told you this before, but I'm going to remind you. Sometimes a graph can cross a horizontal asymptote. Sometimes. Okay? But it can never cross a vertical one. Now, This thing passes through the point 0, 1. Okay, here we switch the domain and the range. Now this one, instead of a horizontal asymptote, has a vertical asymptote. That this can never cross. Okay? And what is the equation of this? Well, this is the equation x equals 0. Notice y equals 0 is that asymptote. Interchange the x's and y's, and x equals 0 is the asymptote of that one. Okay? And whereas this one goes through 0, 1, that one goes through 1, 0. This one goes through 2, 1, 2, 3, 4. And this one goes through 1, 2, 3, 4 up 2. So you see everything is just XY reversed. Okay, we got this, log 3 of x. We don't know what x is. We want to graph it. Well, we can pick some x values. Okay. Can we pick negative x values? No, because you can't have a negative x. Okay. We can convert this to exponential. Okay. Now, in terms of figuring the numbers to go over here, that's the easiest way to do it. Okay. 3 to the 0 is going to be 1. 3 to the first is 3, 3 to the second is 9, 3 to the third is 27. You can use negative powers. You just can't make the 3 itself negative. Okay. Now, if you really wanted to, you could get out your calculator, and I can't imagine for any reason why you would want to do this. Let me clear it. Okay, we could put in log of 3 of 0. Where's my mouse? There we go. Of 0 equals, well, it won't do that one. So log 3 go over and put in a 1 equals 0. Okay. Now, what I'm doing is now I'm just saying what x values I'm putting in here. I'm putting 1 right here, and I get a 0. If I put a 2 right here, log 3 of 2, okay, and I would get that thing. Okay. And you can graph it, and those points are on there. Okay. So this is if x is 2, then y is point, what did it say, 6.3, about 2/3 of the way up. You see, it actually works, but my goodness, it's a hard way to do it. You're almost always going to want to convert these to exponential to be able to figure them out. I just felt like I needed to show you the hard way so you'll know not to do it. Okay, so anyway, we get these all out. Okay, now, here's your graph on this thing. Much easier doing it from that, okay? We could have done the opposite of it and then reflected points, but I'm not sure that that would be any better. But you could have.
I have a question.
Sure, if X is 1, Y is 0. I said that backwards. Then if X is 3, now Y is 1. And if X is 9, Y would be 2 right here. And for these over here, if X is 1/3 right here, 1/3 of the way, then it's going to be -1. So this produces your X values and the resulting Y values that correspond to them. Okay.
So you're using the log 3 of X to find X or to get the X.
I'm converting it to this to get these.
Oh, okay, so you're going to the whatever.
The exponential. Yeah, absolutely. Let's look at this one. This one's got a kicker in it. It's got 2 transformations in it. Okay. Instead of just dealing with the log 2 thing, we're going to shift this thing one place to the left and we're going to shift it up 2. Okay. Now, here's the general form of this. Okay. If there had been a number out here, okay, it would stretch it vertically, make it steeper. Unless it was a fraction, then it'd make it flatter. Right here, if there's a value added or subtracted to the X, then it shifts it left or right, opposite of sign. And then a value here shifts it upward or downwards, depending on sign. Okay, so here's, if you had a parent equation, we're going to take the parent equation, we're going to shift it left 1 and up 2. Okay. Okay. Now, what is this -1 error saying? What is this saying right here? That means that we can't exceed that. Okay. Now, here we got 0, 2, 0, 2, 1, 3, 2, a little more than 3, 3.6. Okay. For the negative, for the 4s. Now, at -1, this will never reach -1. Now I need to show you something. And you need to remember this. There is an asymptote right there created by, I can't write up there, but created by that 1 opposite of sign. Okay. So they start asking you what is the domain in this thing, that becomes important because that's a gap. And it'll never come this side of it because of that. Okay. Now, up or down, not going to matter. Okay, because like I said, you can cross horizontal asymptotes. But that creates a vertical asymptote that you can never cross And that's why they got this here. You notice this one is less than that one. That's x equals 1/2, which is right here. Okay? And I did need to show you that before we leave tonight. So have a good weekend.